In this question, we are given the Taylor series for ln x centered at x equals 1. And here is the series. And we are being given also function f, which is the sum of the first three non-zero terms of the series. And these are really just the first three terms because all of them are non-zero terms. And then we need to calculate the maximum of the difference between ln x, absolute value of ln x, and the function for the interval 0.3 and 1.7, between 0.3 and 1.7. And so in order to do that, let's first write down what the function is. So f of x is equal to the first term is -1 squared, which is positive x minus 1 over 1. Next element is negative x minus 1 squared over 2. Next element plus x minus 1 cubed over 3. So then we need to calculate the difference between ln x minus f of x. And note one thing, with this function, we can show it, it's a little bit tedious and not really required in this question, but we can show that this function is increasing on the interval from 1 to 1.7 and decreasing on the interval from 0.3 to 1, and it actually reaches its minimum at x equals 1. It's equal to 0 at x equals 1. You can just plug it in and see that all the terms cancel out. But the maximum is achieved at the endpoints, and these endpoints are symmetric, so the maximum is achieved at 0.3 or 1.7. And so let's use 1.7. And so then this function, this number we need to calculate, is ln of 1.7 minus 0.7 plus 0.7 squared over 2 minus 0.7 cubed over 3. And so let's pull out our calculators and calculate that number. And so let's calculate this expression here. And this will be ln of 1.7 minus 0.7 plus 0.7 squared over 2 minus 0.7 cubed over 3. And the answer is negative 0.039, or the absolute value is positive 0.39. So we calculated this value to be 0.039, and so the answer is B, 0.039. Thank you, and I will see you in the next video.